Welcome back. In the last session, we had seen the Darlington pair problem. Okay. Maybe now we can go to next problem, which is problem number 4. But before going to next problem, I want to explain little bit. Okay. Yesterday, don't write anything, just listen. In the last classes, right, I told if you take voltage amplifier, right, if you take voltage amplifier, right, your amplifier is nothing but having some input impedance Ri. Then if your amplifier is voltage amplifier, if it is voltage amplifier, what do you mean by voltage amplifier? Input is voltage, output is voltage. Your amplifier will take input as voltage, your amplifier will give voltage as output to your load. That is what your voltage amplifier. Then if I model your amplifier, something like this, because it is a voltage amplifier having voltage gain AV, and whatever signal you give, this is, let us say this is what your input signal Vi, whatever you give, it will amplify with the gain of AV, therefore AV into Vi, and this output, this amplified input is, we are trying to give it to your load, but it is a source for your load, and it will have output impedance, R0, that is what we represent. Now we are going to have, this is what is your output V0. Okay, this is what is modeled because it is a voltage amplifier taking input as voltage, then having some input impedance, then whatever input voltage you have, it is having gain of AV into Vi, and that is what we are trying to give it to load. But remember, because it has R0 also, therefore R0 RL, whatever may be, because your voltage source, your amplifier is a voltage source for your load. This is what is our load, RL. Therefore for your load, then your voltage amplifier is a source, and if you take actual source, this is what your actual source, this is Vs and then Rs. Okay, therefore input is voltage and output is voltage. Then I told, right, because of interaction between Ri and then Rs, right, then ultimately I am speaking theoretically. Okay, then to get, what do you want to get, I am repeating again, Vi is equal to Vs, right. I told that Ri to be infinity, right, because we are designing the amplifier, I am speaking with respect to amplifier, your Ri should be infinity ideally. This is what is ideal scenario. Practically, your Ri should be very much greater than Rs. This is what is practical scenario. Right? Your Ri should be very much greater than Rs. Then, see, if you have this, if you have Ri infinity or Ri very much greater than Rs, what is the advantage? Simple, you will get Vi is equal to Vs. If you don't have the matching means matching for voltages. If you don't get matching of voltages, then means if Ra is not very much greater than Rs. For example, if Ra is equal to Rs, then your Vi will be equal to Vs by 2. Your overall gain will decrease basically. See, the requirements of Ri and R0 to improve your voltage gain or to utilize the available voltage gain. You understand the point? Okay, that's fine. Now, coming back to output side, what I want to get V0 is equal to AV into Vi, whatever signal which can be amplified by your amplifier, I want to apply that entire voltage to your load, but because of R0, some drop across R0, therefore we don't want to see any drop across R0. If you don't want to see any drop across R0, what should be R0? Therefore R0 should be 0. This is what is ideal scenario. I want R0 should be 0, but practically R0 should be very much lesser than RL. If R0 is very much less than RL, then you can consider that it has good output impedance matching, right? I already explained this point, right? But now what I want to say, I'm trying to use this as a reference to explain something else which is for current amplifier. Now this is for voltage amplifier. Typically by default I want for voltage amplifier only. Example, op amp. Op amp is a voltage amplifier. Therefore input impedance to be infinity, output impedance to be 0. Therefore to achieve those things, I told you, right, CC amplifier at the input stage which will give you 1.7 mega ohm or 1.8 mega ohm, and CC amplifier at the output stage which will give you 40 ohm, 50 ohm, which is what is your output impedance. Okay, done. Now coming back to current amplifier. When I say current amplifier, what do you mean by current amplifier? Your input is current. Basically the amplifier is looking for current. Therefore this is what is our input impedance. Your amplifier will have definitely input impedance, Ri, because this is what your current amplifier. I am speaking about current amplification, means your input excitation is current source. Therefore whatever current, let us say the current which is entering into your amplifier is I1, right? Whatever current which is what is entered into your amplifier will amplify that current. Our amplifier will amplify the current with what? With current gain of AI. Let me take it as AI. How you told AB as voltage gain, I am just taking AI as current gain. Therefore whatever current you have, AI into the current which is entering into your amplifier will amplify it. Therefore AI into I1. And let me tell you one more point. See, if you take a load, I'm just modeling your amplifier with respect to this. If you take a load, you are going to connect load here. Then current amplifier will give current to the load. When I say current to the load, for your load, current amplifier is nothing but current source. When I say current amplifier is current source, the current source internal resistance should be represented in parallel to it. Okay. Therefore, this is what it is. You can say this is what is your R0. Maybe the definition of R0 also will be satisfied. If you are confused, you can take all these terminals as common, and that is what is your common terminal. But the common terminal can be shorted to ground, let us say. Okay, what it may be. Now, this is what is going to give you the load current. Now, the source is connected. What source? Now, not voltage source. Because I am speaking about current amplifier, it should be excited with current source. What source? Practical current source. When I say practical current source, it will have IS and RS. Okay. This is what is your RS. Similarly, whatever current you are getting from your current source, that is what you are trying to pump it to your load. Therefore, let me take it as IL. This is what is your IL. Okay. Anything is fine. Okay. This is what is your IL. The current which is what is coming out of your amplifier with respect to current flow. Okay. Now, what do you want? Whatever current which is what is entering into your amplifier will amplify with gain of AI. And whatever current which you are getting after amplification, that current should enter into your load only. But because of R0, part of the current will enter into R0, only partial current will enter into load. That we don't want, right? Therefore, now let's see with respect to current section. To get I1 is equal to IS. Even though there is RS, I don't want to see any current which is flowing through RS. I want to see current to be entering into your amplifier. Therefore, to get I1 is equal to IS. To get I1 is equal to IS. Tell me, what should be Ri? The Ri should be what? Ri should be 0. I am speaking with respect to amplifier only, because you are designing amplifier. Therefore, you should know the specifications to meet current amplifier impedance matching. Okay. Here, what should be Ri? Ri should be 0, and this is what is ideal scenario. Why? If Ri is 0, can I say short circuit? Short circuit in parallel to RS. Short circuit, current always takes lowest resistance path. Therefore, it has two branches, either RS or ground. Therefore, it takes directly the lowest resistance path and then enter into ground. Therefore, that is what your I1. Then I1 will become IS. Therefore, what should be input impedance? It should be 0. Therefore, this is what is called input impedance matching for current. Therefore, to match I1 to IS, what is Ri? Ri should be 0. Therefore, don't always say that Ri to be infinity. That is true only for voltage amplifier. I am just highlighting this point again and again. Don't blindly say I want Ri infinity. Ri infinity for voltage amplifier. Practically we use voltage amplifiers, therefore Ri infinity. But if you want current amplifier, let us say there is a requirement where I want current amplifier, then the Ri should be 0. Okay, this is ideal case, but practically the Ri value should be very much less than the source resistance. This is what is practical condition. Okay, now coming to output side. Now output side, whatever current which you are trying to pump into the load, I want that entire current to be AI into I1. Whatever it is amplifying with the gain AI, that entire current should be entered into your load. But because of R0, partially it is going or bypassed. Now to get, now the condition, to get the load current IL is equal to the amplification version of your input current AI into I1. Right? Then tell me, number one, because you are designing your amplifier, what should be R0? R0 should be infinity. Basically, it should be ideal current source. Here, basically, we want ideal voltage source. Therefore, R0 is 0 because voltage is your output. See, because current is output, I want ideal current source because your amplifier is a current source for your load. Therefore, I want ideal current source. Simple. That is to remember. Simple to remember. Therefore, if it is ideal current source, I want R0 to be infinity. For ideal current source, what is internal resistance? Infinity. Even though we are represented with capital letters, remember this is to speak with respect to AC parameters, whatever we had seen, Ri, R0 and all. I told you the AC parameter because it is a gain parameter, voltage to current, we are represented with the capital letter, but don't think that is DC parameter, that is AC parameter only. Okay. Therefore, R0 to be equal to infinity. This is what is ideal scenario. What is practical scenario? Your R0 should be very much greater than RL. This is what is practical scenario. The amplifier which satisfies this relationship, then it is said to be having impedance matching for current amplification. Okay, take it. Maybe if you want to take this voltage amplifier also, you can take it because I am using this as a reference for me to explain current amplifier also. Maybe it's better if you take these two side by side. Okay, because both are having same format. Okay, earlier I explained with a different format. I'll wait for one more minute, then I'll start the next problem. Okay, problem number 4. Over? Okay. Now, let's see problem number 4 from your workbook. What is problem number 4? If you refer the workbook, calculate all AC parameters for the following circuit. Okay, assume that complete AC circuit is given. Okay, here complete AC circuit is given. I think it is straightforward. Now the circuit is RS is equal to 1 kilo ohm. In all the problems, if you see, the VS is given, sorry, VS RS same source is given, but now this is what is applied to, this is AC ground basically, and now remember completely AC circuit is given, and assumption is also given that assume the transistor is in active region. Actually that is what we need for amplification. Okay, therefore it is in active region. Fine. Therefore now this is what is our input voltage, and this is input current, what it may be, and this is what your output voltage, right? Therefore now this is what is our black box. When I say this is what your black box, and exciting with a practical voltage source and connected a load, right? And the current which is entering into your load, this is what your load current, what it may be. Now this is AC circuit, right? Now AC circuit is given straightforward. Okay, that is fine. Therefore this is nothing but your AC ground. That's fine, no need to represent. If you know that it is ground, AC ground or ground, it is same in the case of AC analysis. Fine. Now according to our procedure, AC analysis or DC analysis, definitely AC analysis. Next step, find the configuration. What is this configuration? Applying input voltage at emitter with respect to ground, base is at ground, taking output voltage at collector with respect to ground, base is at ground. For both input and output, base is common. Therefore this is common base amplifier. This is common base amplifier. This is common base amplifier. Okay. Therefore, let us calculate the amplifier or the black box. What are you have? AC parameters like current gain, voltage gain, input impedance, output impedance, right? Let's see. I think this is what is the problem. Now, let's say same RL. Whatever we have seen till now, RL is 10K. Therefore, this is easy to compare for all the configurations. Same load, same source. Only configuration is changing. Therefore, we can have the comparison between one configuration to another configuration. That is the reason why I have taken the same source, same load for all the problems. Okay. Now, let's see the first one. According to our analysis, the first one, current gain. What is current gain? Current gain is nothing but, because this is common base amplifier, minus HFB divided by 1 plus HOB into RL. Minus HFB divided by 1 plus HOB into RL. Then you substitute. What is HFB? I gave. If you want to convert into CH parameters, you can convert, but let us substitute and get. Therefore, minus into minus plus 0.98. Therefore, this is 0.98 divided by 1 plus, what is HOB? 1 by 2.01 mega ohm into RL, 10K. What is 10K by 2 mega ohm? Let me take it approximately 2 mega ohm, which is 2000 kilo ohm. KK will be cancelled, 10 by 2000, 1 by 200. Can I neglect 1 by 200 with respect to 1? Yes. Then it is approximately equal to 1 but less than 1. It is close to 1, actually 0.98 or 0.97 something. Therefore, this is what is the first one which we got. You can keep in bracket. That is the answer. One of the AC parameters. Now, let's see the second one. What is the second one? In our flow, the second one is Ri. Therefore, what is Ri formula? HIB plus AI into HRB into RL. Right? What is HIB? HIB is nothing but 22 ohm, actually 21.9. You can take it as 22 plus. What is AI? Approximately 1. What is HRB? 2.9 into 10 to the power of minus 4. And then RL 10K, which is 10 to the power of 4. Tell me 10 to the power of 4 into 10 to the power of minus 4, 10 to the power of 0, which is 1. 1 into 2.9, 2.9, 22 plus 2.9, 24.9, approximately equal to 25. Let me take this as 25. Therefore, this is your input impedance. This is your input impedance. Okay. Now, let's see the third one. Voltage gain. What is voltage gain formula? AV is equal to AI into RL divided by RI. Then what is AI? A is already calculated, approximately equal to 1. What is RL? That is 10K. And what is RI? That is 25. Then what is 10K by 25? 10,000 by 25, which is 400. Therefore, what is AV? AV is equal to 400. This is the third AC parameter. Okay. Now the last one, output impedance, right? Therefore, what is R0? R0 is nothing but 1 by Y0, right? We know that. What is Y0? We know that Y0 is equal to HOB minus HRB into HFB divided by RS plus HIB, right? Maybe if you substitute, you will get the answer. Therefore, what is Y0? Y0 is equal to HOB. What is HOB? 0.49 microampere per volt minus HRB 2.9 into 10 to the power of minus 4. HFB approximately equal to 1 but minus, then it has become plus into, I am taking approximately equal to 1, strictly speaking 0.98, which you can take it as approximately equal to 1 divided by RS, that is 1 kilo ohm plus HIB 22 ohm. Therefore, can I neglect 22 ohm with respect to 1K? Yes, I can neglect it. Therefore, if you see here, this is 0.49 micro plus 1K. Can I say 10 to the power of 3? That will become 10 to the power minus 3. Then it is 10 to the power minus 7. 2.9 into 10 to the power minus 7 is 0.29 10 to the power minus 6, which is micro. 0.29 micro. 0.29 micro. Then what is this? 0.49 plus 0.29? 0.78 micro ampere per volt. This is what is our Y naught. But we want R naught. Therefore R naught is equal to 1 by 0.78. The micro will become mega ohm. Therefore, what is 1 by 0.78? Can I take it as approximately 0.75? Then what is 0.75? 3 by 4, then it will become 4 by 3. You will get approximately 1.3. Therefore, you will get approximately 1.3 mega ohm. This is what is our R naught. If our problem is over, we are able to solve all AC parameters. Maybe remember, in the examination, if one of the AC parameters is asked, then anyway you need to take appropriate formula and then substitute, you will get the answer. But remember, the H parameter values will be given in the examination. You don't need to by heart the values which I gave, the typical values of a transistor, but you can continue with the problem statement H parameters. But everybody understood the procedure. But remember, whatever formulae we derived, like 4 formulae, generic, right? Voltage gain, current gain, input impedance, output impedance. We are using only these things to solve all the the parameters for all the configurations. Okay, those 4 are very important. Need to by heart. I don't know how will you by heart. Okay, then we'll have observations. See, if you ask me, in my case, I always look for observations. I am not bothering about all these things. If you know the procedure, if you know the concept, solving all these things, nothing, straightforward. But only observations, the theory related to the problem, then only you'll understand the practical concepts of any problem. Right? If you understand all those things, when you do all these things in the as experiments in the lab, then you can have the observations. That's why when you do lab, there is a book called observation book, right? And after doing all the observations from experiments, then finally we have to write a conclusion. That is very important. That is, what did you conclude from the experiment? Similarly, what did you conclude from the problem? I am treating each and every problem is an experiment for me. If each and every problem is an experiment, right, we should know the theory corresponding to the experiment. Therefore, actually we should know the theory and then do the experiment. Now, we are trying to do experiment along with the theory knowledge. Therefore, both covering practical aspects as well as theoretical aspects. Okay. Till now, how many configurations we have seen? Common emitter, common base, common collector. Okay. We have 3 configurations from BJT because we have 3 terminals. Any one of the terminals can be common. Therefore, 3 configurations: common emitter, common base, common collector. Maybe we can add few things for the configurations to achieve something, but whatever maybe, we have only 3 configurations. And whatever formulae we derived initially, right, those formulae are valid only for these 3 configurations. If they are in cascade, we already did right for Darlington pair, yes, you can apply. But like stage wise, stage 1, we need to calculate stage 1, stage 2 parameters and then you can combine using system analysis, control system analysis. G1 of S into G2 of S, that is what is your overall gain. Similarly, we calculated AV1 into AV2, that is overall gain of CC amplifier or Darlington pair. One more minute time, after that I'll start some theory. Let's hold on for few more problems. That's what, if you want to solve few more problems, then we should know few things. Those things let me discuss, okay, which are nothing but simplified model, etc. Okay, let's see. But first of all, we should have observations. Let's have observations after this. Maybe that part, the continuation, we can do next session. In this session only we can have observations and then we can stop. Okay. Done? Okay. Now observations. Okay. Now if you see the observations, don't go for AVI. Let's see RI R0. What is it suitable for? Okay. Tell me what is RI. The input impedance of your common base amplifier is 25 ohm. Is it high or low? With respect to what? We always try to compare with respect to RS. Right? Therefore, with respect to 1 kilo ohm, what is your RI? Therefore, what is your RI? RI is equal to 25 ohm. With respect to 1K, RI is very low. Right? Therefore, indirectly it is providing shortest resistance. Right? Therefore, the input impedance is very low, suitable for current input, because when you excite with current source, entire current will be entering into your amplifier because it has low input impedance. It has very good input impedance matching for current input. Okay. Now, what is your output impedance? Your output impedance, right, R0 is equal to 1.3 mega ohm. Is it very high? Yes, it is very high with respect to 10K, sorry. Therefore, it is very high, and we want very high output impedance for current source. Therefore, if your amplifier is acting as a current source, I want internal resistance to be infinity, then entire current will be entering into your load. Therefore, your CB amplifier is providing very good impedance matching for current amplification. It is providing very good impedance matching for current amplification. But what is current gain? Current gain is 1. It is exactly similar to your CC amplifier. Is it not? Yes, right? Write down. Whatever we got, the observations. We are observing, okay? Write down. First point, observations. First point. Common base amplifier is providing very good impedance matching for current amplification. Common base amplifier is providing very good impedance matching for current amplification. Common base amplifier is providing very good impedance matching for current amplification. But current gain is unity. Current gain is unity. Therefore, actually common base amplifier is providing very good impedance matching for current amplifier, but it doesn't have current gain. Therefore, overall, if you want to develop current amplifier, right, maybe you can look for a circuit where it is giving current gain. It doesn't need to satisfy the impedance matching for current amplifier, but we can use CB amplifier at the input stage and CB amplifier at the output stage, then get current gain from the amplifier which is giving current gain, then you can get current amplifier, which is exactly similar to voltage amplifier block diagram what I had given, which is like combination of CN and CC. Okay, now write down. Common base amplifier is also called as current buffer amplifier. Typically, if you say buffer amplifier, default voltage buffer, no need to specify voltage buffer amplifier. But here it is current buffer amplifier because it is doing buffer action for current. Specifically, we need to specify. Okay. Therefore, current buffer amplifier. Common base amplifier is also called as current buffer amplifier. Okay. Okay. From overall observations, right? If you see, what is your conclusion? The conclusion is your common base amplifier is providing very good impedance matching for current amplification, but current gain is 1. If you take common emitter amplifier where you have current gain 40, but there is no impedance matching for voltage amplification, no impedance matching for current amplification, then what we can do, we can use common emitter amplifier is core amplifier to get current gain, and CB amplifier at the input stage, CB amplifier at the output stage, then it will be overall current amplifier providing impedance matching for current amplification using CB amplifiers and providing current gain from CE amplifier. Therefore, we are extracting current gain from CE amplifier and providing impedance matching from CB amplifier. I hope this is clear. It is similar to your CC, CE, CC, but that is voltage amplifier. Now this is current amplifier. Write down conclusion, then I'll give you block diagram. Okay. With that, the session will be over. Okay. Write down conclusion. We can combine CE amplifier. We can combine CE amplifier along with CB amplifiers to extract to extract voltage, to extract current gain from common emitter amplifier, to extract current gain from common emitter amplifier, to extract current gain from common emitter amplifier, and impedance matching both at input and output, and impedance matching both at input and output, impedance matching both at input and output using common base amplifier, using common base amplifiers, using common base amplifiers, using common base amplifiers for current amplification. This is important. All these things for current amplification. For current amplification. For current amplification. Quickly you can take the block diagram. Okay, now the block diagram is, actually this is what is our common emitter amplifier, CE amplifier. We are extracting current gain from CE amplifier. Earlier also we used CE amplifier to get voltage gain, because only CE amplifier is the one which is what is having both voltage gain and current gain. That's why use power gain. Only CE amplifier is having power gain, not CC amplifier, not CB amplifier. Okay, that part I'll explain later, but now only that is what. Therefore, when you are trying to develop voltage amplifier, we used CE amplifier to get voltage gain. Now also I'm using CE amplifier to get current gain. Okay, even if you want to implement current amplifier, but remember this is not so popular because nobody uses current amplifier. Everybody uses voltage amplifier using op amp. But still remember, if you want current amplifier, we can get using op amp. That is one of the applications of op amp which we see in the case of op amp. Okay, how to get voltage source, how to get current source or current amplifier from op amp. Okay, now this is what your current amplifier, and the input stage, this is for impedance matching. This is what is our common base amplifier. Okay, that output is given to this, and again this is what is common base amplifier, CB amplifier. Now this is what is the, now let us excite with current source, because now current amplifier I am saying. Therefore when I say current amplifier, now we need to excite with current source. This is your IS. Now this is what is your RS, and the current which is entering into your common base amplifier is I1, and load is connected here, and the current which is entering into your load is nothing but your IL. Okay, now if you ask me what is current gain, the current gain of common base amplifier is approximately equal to 1. The current gain of common base amplifier is approximately equal to 1, right? Then what is input impedance? The input impedance, right? Let us say this is what your input impedance. What is input impedance of common base amplifier? That is nothing but, we saw, right? Let us take the example. Therefore approximately 25 ohm. And what is R0? We got R0 1.3 mega ohm. What is input impedance of common emitter amplifier? We already saw, right? approximately, not completely, approximately 1 kilo ohm. And what is R0? What was R0? We got approximately, you can say 50 kilo ohm, 52 kilo ohm. Now for your common base, what is your input impedance? Approximately 25 ohm. And what is our output impedance? Approximately 1.3 mega ohm. And remember, this is what is your block current amplifier. Therefore overall, this is what is our current amplifier, right? This is what is our current amplifier. Okay. Maybe let's continue in the next session because time is not there. Okay. The same thing will be flashed. Okay. No need to draw now in a hurry way. The same thing will be flashed in the next session. Okay. If you want to continue, let me stop here. But what else maybe 2 minutes I can continue and then I can stop. But don't draw. Even though the session is over, it will be continued in the next session. Now this is what is our current amplifier. When I say current amplifier, overall, and it is having. Now see, maybe if you want, this is what your RS. Now tell me what your RI. RI is equal to 25 kilo ohm. Almost your IS will be entering into your amplifier. Then current gain is 1. The same current will be coming out of your common base amplifier. Now, because what your output impedance 1.3 mega ohm, what is your input impedance 1 kilo ohm. With respect to 1.3 mega ohm, what about 1 kilo ohm? That is very small, right? Then almost it's like a current source. Then it will enter, the current which is what is coming out of common base will enter into common emitter amplifier. Whatever current which is entering into your common emitter amplifier, it will amplify with the gain of AI. Then that current will be given. Now your RA is very less, the enter current will be entering into your common base amplifier and gain is 1, therefore ultimately you will get IL is equal to AI into IS, because your I1, because RA is very less, your I1 is equal to IS. Okay, let me stop now. I'll continue with the same flash. Okay, thank you.